Welcome to myprojectbazaar.com. Project title: Green Cell Planning and Deployment for Small Cell Networks in Smart Cities. Let's see the abstract of our process. We have doing the enhancement work of the base paper. First of all, the cellular network are in a major transition from a carefully planned set of large tower-mounted base stations to an irregular deployment of the heterogeneous infrastructure elements that often additionally includes micro, pico, and femtocells, as well as the distributed antennas. The future 5G network aims to build the infrastructure from mobile internet to connected world. Small cell is one of the most promising technologies of 5G to provide more connections and high data rate. It is particularly a challenging task to deploy dense small cells in the presence of dynamic traffic demands and severe co-channel interference. Interference is a fundamental limiting factor in throughput performance in a heterogeneous cellular network due to the resource sharing between tiers of base stations. Smart cellular network deployments are becoming saturated in areas with high density of users, such as in urban environments. Also, high traffic is occurred in the network, which is a major concern in the smart city network. Hence, the deployment of the network is depending on the smart cells with energy efficiency. The simulation results shows that the proposed system is efficient in the deployment of the nodes in small cells. Let's see the flow diagram of our process. First, the network is formed with the number of nodes. These nodes are deployed in the macro and the pico cells with the base stations. The users are represented as the user equipments, which is considered as the nodes in the network. After that, the dynamic allocation for the users is processed for the active or the sleep base stations. After that, the traffic is measured. If the traffic is high means we have to change the base stations to allocate the channel. If traffic is low means then the base stations will assign the channel to perform communication. After assigning the channel, the data transmission is provided in the network between the users. Finally, the performance is analyzed in which the existing system is compared with the proposed system in terms of its matrices like the delay and the throughput. Now we are going to see the output demo. First, open the terminal window, then go to the directory where we have the code, then type ns space filename.tcl. Now the nodes are created and that the code is running now. The position of each and every user equipments are updated because as per it the channels are assigned for the base stations. The animator window shows the output of our process. First, maximize the window. Here the nodes are deployed in the network. For run the simulation, click the play button. Here the base stations are created in the network and the user equipments are represented in different color. We can speed up the simulation process. Here the user equipment start communicate with the base station. These are all divided as the cells, that is the small cell network. From the user, the packets are first transmitted to the nearby base stations and from this base station it transfers to the macro base station. The small cell base station and the macro base station is accessed by the backhaul link. The users and the small cell base station is accessed by the access link. These are all the MAC that is the coverage area for each and every node in the network. This represents the cell planning, and also the green cell is find out in the updation process of the energy. Green is mentioned as energy of the network. After the simulation is completed, to see the graph, back to the terminal window, then type GNU plot graph name dot plot. This is the delay graph. Here the number of nodes are varied, and find out the end-to-end delay for packet transmission for each and every node in the network. For this, we have less end-to-end delay than the CPX process, that is the existing work. They propose to have a higher performance. To see the another graph, type GNU plot graph 2.plot. This is a throughput graph for the comparison of the CPX and the proposed system. The proposed system have higher throughput rate than the existing work. This throughput are measured in Mbps. That's all. The overall performance of the proposed work is increased than the existing systems. That's all. The demo is completed now. Thank you for watching this video.